We have all heard of climate change in everyday news. In the last centuries, human activity has caused an increasing amount of carbon emissions, leading to the warming of the earth and various environmental impacts on the biodiversity, quality of the air and water, human health, and more. According to scientists, in a high-emission scenario, the climate of Amsterdam in 2050 could resemble the current climate of a southern French city. As the global population grows, the demand for food will keep on increasing. The food and agricultural industries are significant contributors to these emissions. This is why the topic of the protein transition has recently emerged, the shift from traditional protein sources to alternative ones. Although insects have been consumed by humans for millennia, they are not common as a source of food in the Western world, and they are mentioned increasingly often by scientists as a potential future source of sustainable protein.
But what in fact is sustainability? Sustainability has to do with meeting the needs of our current generations without compromising the needs of the future ones. Sustainability comprises three dimensions: social, ecological, and economical. This episode will focus on the ecological aspect.
Today's episode will try and answer the question, is insect consumption sustainable? To evaluate this episode will cover three aspects: carbon emissions, use of resources, land and water, and farming practices. Regarding our first criteria, carbon emissions, there is a clear difference between protein sources. We will use the example of the two most commonly raised insect species, crickets and mealworms. Compared to meat, beef for example, they emit from 70 to 99% less greenhouse gas emissions per kilogram of protein. Plant protein remains the least carbon-emitting protein source, as those same insect species still emit up to 6 times more carbon than soybeans. However, technological development will play a big role in the environmental impact of all protein sources. Current practices in the industrial insect production still need to be optimized, as cricket production emits more than broiler chickens, for example. Note that some insect species, however, can have negative environmental impacts, such as beetles who produce methane, a gas far more polluting than CO2. Environmental impact is much more complicated than simply carbon emissions, and this episode will not cover the total amount of criteria, as that would take forever. However, we can compare the use of some natural resources. It is estimated that agriculture uses 70% of water globally. When comparing mealworms and beef to extreme examples, it is estimated that beef uses up to 14 times more land and 5 times more water per gram of protein than mealworms. Once again, grain protein remains lower, as 2 or 3 times more land and 50% more water are needed for the same amount of chicken protein. This is why directly consuming plant protein is often considered as most sustainable. According to certain studies, current estimates of resource use for insect farming are comparable to the farming of certain fish species.
Now let us take a step back and observe the insect production system in a more general way. A positive aspect of insects is that they can be easily recovered into the supply chain and avoid protein waste. That being said, the type of feed used for animals and for insects has a big impact, as well as the circularity of the materials. For example, mealworms can be fed dried organic waste.
Let's now take a look into an insect farm. What do these new types of farm actually look like? Insect farms are very different from the typical cattle farm, where there are green fields and large stables. On a cow farm, for example, a large insect farm looks more like a factory. The insects are reared in trays, just like this one. In one of these trays, there might be close to 1 million insects. These trays are then stacked on top of each other, making them easy to store and to transport. Sitting close together is a natural behavior for a lot of insects, meaning this is not a disturbing practice for them. And these large numbers are necessary because one insect burger needs about 3,000 insects, where a beef burger would only require a small part of a cow. But even with this very large number of animals needed to feed even one person, these insects are still using less food and water than conventional livestock per burger. Let's make a comparison. For 100 grams of crickets, around 170 grams of feed is needed to let them grow. This may seem like a lot, but when compared to 100 grams of chicken, 250 grams of feed are needed. And for beef, even more. A kilogram of feed for 100 grams of beef. This is 10 times as much feed as what we actually eat from the cow. For insects, this is only 1.7 times as much.
The big difference can be explained by the fact that insects are cold-blooded, where cows are warm-blooded. This means that insects don't lose energy to heat up their bodies, instead converting it into body mass. This difference in food demand is one reason why insects take up significantly less land to grow.
For some of these insect species, the feed can be made up entirely of grass. If monitored carefully, we could rear these insects in some of our waste streams. Right now, EU legislation limits the use of insects due to health safety concerns, but is allowing more and more insects on the European market. And with proper monitoring and care, it is possible that we could use insect waste in the future, adding to the circularity of our food system. Especially in the Netherlands, this could help tackle the massive manure overproduction. This sounds like a solution, and it could be, but farming insects is of course not perfect. The farm itself does cost more energy to run than a cattle farm. And this is because of the fact that the insects need to be kept at a constant 30 degrees Celsius to keep growing fast. At this temperature, they can reach adulthood in about 3 weeks. When insects have grown enough, they are killed and shipped away to the customers. The ways of killing the insects vary, but one of the easiest ways is to lower the temperature to 10 degrees Celsius. Because of their cold-bloodedness, the insects will fall asleep and die. This makes killing them quick, and it can be done in large numbers. Therefore, we can conclude the following. Assessing the environmental impact of insect consumption is very complex, and so is comparing it to other protein sources. Insects have a real potential for sustainability if it is done right. Indeed, the industry remains niche in the West, and its development could impact developing countries. So, what do you think? Which will be the protein source of the future? Soy burgers, cricket burgers, or the traditional beef burger if the meat industry improves its technologies? Only the future will tell.